Our power grid acts as the backbone of modern society. More than ever before, electricity runs almost every aspect of our lives, from the lights to our phones to cars. We can safely state that we can't live normally without a reliable power grid. For a grid to be reliable, one of the fundamental aspects is the durability of the transmission line poles responsible for maintaining the flow of electricity from its source to us. Yet there are specific shortcomings that come with our existing solutions. This video intends to cover some of the challenges that exist currently with our most common transmission pole material, and how the industry is turning towards a composite material solution. Traditionally, the well-established material for utility poles are wood, steel, and concrete. For the purposes of this video, we will focus on wood poles as they make up most transmission line poles. Though they're sufficient in fulfilling their purpose as we've been using them for decades, it does have a few aspects where we can improve: environmental, economic, and functional. For one, environmentally, as we know, wood poles come from trees contributing to deforestation. For reference, deforestation contributes to our climate crisis, habitat loss, and ecological disruptions. Not only this, but wood poles are often treated with preservatives that may leak toxic material into its surroundings, which may affect human health as well. Although there are strict regulations to prevent this, these regulations are not totally foolproof since they are still subject to changes according to new discoveries on the effects of various substances. For example, just last year in 2022, Health Canada and the United States Environmental Protection Agency banned the preservative penta due to its impact on workers' health and its toxicity. Now, economically. Wood pole prices are increasing while labor to transport, install, and maintain them remains costly and strenuous. Workers are required to not only transport these massive poles that typically measure up to 125 feet by helicopter or truck, but to also perform regular checkups and maintenance throughout its service life. Over time, these expenses can add up. And lastly, functionally, wood poles generally last around 30 to 40 years with maintenance, are subject to decay, wind damage, heavy weather, fire, insects, and even woodpecker damage. Wildfire damage is especially relevant to the west coast of North America. Due to climate change, wildfire season is threatening more homes and structures every year. Another significant local issue is woodpecker damage, where woodpeckers, most notably pileated woodpeckers, wreak havoc on structures in the grid. In fact, there have been many attempts from experts to tackle this issue, from trying to understand why they tend to attack wood poles to coming up with band-aid solutions to prevent and to repair woodpecker damage. These three problematic aspects call for a solution to strengthen the power grid's poles structurally. Of the possible solutions, engineers and other experts have determined that FRP, or fiber-reinforced polymer poles, may just be the answer, as well as being a potential leading material in our future. Although more costly to buy at the time of purchase, the FRP pole improves the aforementioned shortcomings of the wood pole. Firstly, while wood poles contribute to deforestation and can affect the ecology around them, FRP poles are, at its essence, an advanced man-made composite that's environmentally inert, making it a greener choice that does not harm human health or other creatures. This is because their manufacturing process is less harmful to the environment and they do not require treatment or preservatives. Secondly, companies save in installation and maintenance costs. They are much easier to transport as they come in smaller modules and are significantly lighter than other pole materials. They also don't require regular maintenance like wood poles, greatly reducing ownership and operational costs. As you can see here, industry-leading RS Technologies FRP poles are the lightest of the alternative materials and are over 3 times lighter than the wood poles of the same class. Now functionally, an FRP pole can last double the lifetime of wood poles. RS Technologies claim that their FRP poles have an 80-year service life. Moreover, its material strength to weight ratio wipes the floor against the wooden counterparts or any other material, increasing its reliability as well. For instance, while one of the stronger types of wood pole species, Douglas fir, has a strength to weight measurement of 272 pound per square inch per cubic feet per pound, FRP poles from RS Technologies has around 630. This is over double its wooden counterpart. As such, it usually serves as a better alternative. Adding on to this, the FRP pole is rot, corrosion, and pest resistant, as well as UV protected. These characteristics make it even more resilient to the challenges that wood poles face, such as wildfires, extreme weather, and other ecological disturbances. Its non-toxic, hydrophobic, and non-conductive properties also increase safety for workers. Because of these reasons, FRP poles are decidedly a fast-growing industry. Experts forecast this market to grow to $292.1 million in 2026 from $206.3 million in 2020, with North America being its largest FRP pole market. Ending on a fun fact, though FRP poles are gaining popularity now due to the increasing demand, they have been used in the industry since the 1960s. So they aren't a new technology that had just been discovered. We've actually known about it for decades. All in all, FRP poles address and tackle many of the challenges that wood poles face as the needs of the modern power grid continue to evolve. Even within West Power Energy, our engineers have been seeing more FRP pole forward designs within the past decade as the transmission line industry has been shifting from wood pole solutions to FRP solutions. This industry is directly affected by our ever-changing environment and habits. In the next century, we will probably see even more discoveries as we continue to adapt to support our increasing energy-dependent modern lifestyles.